Hi, Mr. Hayes back, and I am here to walk you through the discovery method of how to solve or factor perfect cubes. So I'm going to walk you through a lesson that we did in class, and then hopefully that'll help give you some, instead of just memorizing formula, you can actually understand what's going on. So the first thing that we did in class was we did some review of factoring, and we had talked about perfect squares and perfect squares and difference of perfect squares and how those work when you're factoring. And then I gave them this problem. And in this one, usually I asked the groups to go through and say, well, what do you notice about it? Let's not worry about factoring. And usually somebody will say, well, wait a second. 64x cubed is 4x cubed. And 27 is equal to 3 cubed. And it's usually, little side note here, a really good idea to know what the cubes are of the numbers like 1 through 10. So, when you have a second, just write down, I would just, do the squares 2, 4, 8, 3, 9, 27, etc. Then that way you're not reaching for the calculator for everything. So anyway, I then tell the class I want them to figure out two binomials that should get to this. And some people are thinking, hey, maybe this is, this might be 4x plus 3 cubed. And I said, well, and that's why I tell the classes that I'm looking for binomials. And from there, usually what will end up happening is classes will start with this. They're going to start with the cube roots. From there, they start messing around and they start playing around with other binomials and other trinomials to see what works. One of the podcasts I listen to says, hey, let's worry about the extra stuff later. That's a problem for future us. Okay, for right now, let's just kind of do what we're going to get through. And so I asked them, I said, so what do we need to multiply 4x by to get to that 64x cubed that we want? And everybody is like, oh yeah, that's going to be 16x squared. So we put down 16x squared. And then I said, okay, so what gets us to the 27 that we want? And they're like, oh, that's going to be 9. So it's like, okay, so there's the plus 9. So then I ask them to multiply it all the way through. And when they multiply it through these two binomials, obviously we get 48x squared, and we also get 36x here. So then the next question comes up, and like, well, how do we, so there's, now that's the problem for future us. Now, it's now the future, so how do we deal with those? And invariably, somebody in every class will say, well, wait a second, that's equal to 12x times 4x, and this is equal to 12x times 3. And if not, then what I do is I ask, okay, so how can I use the 4x and the 3 to get there? Because obviously whatever we need to put into this to eliminate that, so in other words, we need to get this to become a negative 48x squared, and we also need a negative 36x. So we can get rid of those extra pieces there. So anyway, so I asked that. They usually kind of come up with it. They notice that 4 and 3 are used here. So then they're ending up saying, okay, I want to make these negative. So since this is the same common factor between our two things that we're trying to eliminate, I'm going to put a negative 12x there. And everybody's kind of happy with that. And so I will then go through and I'll say, okay, so we have 4x plus 3. We have a binomial times a trinomial. And so from there, I'll say, all right, well, let's categorize these parts. Because let's face it, when you memorize things that are just letters and variables, you don't necessarily understand what's going on. And sometimes it's harder to memorize. But when you go through and you say, okay, these are the cube roots. And I should probably also put 64x to the third plus 27 here. And then these are your roots squared. And then this is the opposite and so everybody feels good about that. So everybody thinks that that works pretty well. So we take this idea and we expand it into another problem. I've moved in our little reference, and I usually have this on a sideboard. since you can't see my dry erase boards, I had to put it over here. And then we're just going to play around with this. So again, I would have 2q as my first cube root. I have 5 as my second cube root. So if I do the binomial, that should be 2q plus 5. And then I'm going to have 4q squared minus, because we need to have it be negative, and we're going to multiply those together, so a negative 2q times. The opposite of 2q times 5 would be a negative 10q, and then plus 25 at the end. Now, the one thing I wish I would have added was saying, okay, this is going to be positive. And so the sign's going to go with it, because since it's negative and you're doing cube roots, it should always work. And so then the students will, so they try it up on the boards, they move it around, they multiply it out, and they're like, hey, this works too. And then from there, I move it into, okay, so here's the general form. Well, actually, I take it back. We do it one more time. So they'll go through this. So again, why don't you do this? Hit pause, try it. We'll come back in a second. All right, welcome back. So this is going to be R. This is going to be a negative 2s. And so if we go through and follow the pattern, it is the cube roots times the 2 squares of the roots plus the opposite of the product of the 2 roots. And again, if you go through and you multiply all of this out, you'll see that this right here, the negative 2r squared s, is taken out by this positive 2r squared s. And the same thing happens from there. From there, I go through and I just show them the basic formula here. But again, this right here, most of the time people don't need, because they're remembering that it's falling out to become, you've got your cube root 1 plus cube root 2 times your root squared, root 1 squared, cube root 1 squared, minus cube root 1, cube root 2, plus root cube root 2 squared. And again, since you've learned it conceptually, it doesn't often take that much more time. You just kind of learn it because you're doing it step by step. So anyway, I hope that's helpful. Try a couple, comment down below, like, subscribe, all that other good stuff that you know, and we'll see you soon.